Unreal's PCG Biome system is awesome, but it's extremely complicated, I'm not gonna lie. It has a lot of control, but you really have to do things a certain way, and it doesn't support certain things, like for example, using it with just static meshes. So what I decided to do is create my own biome system, thanks to a little bit of PCG-EX, and just some basic PCG knowledge. We can get something like this, a full biome system that also works with static meshes, so you can project even on static mesh, and it is fully set up with partitioning, and you can control it however you'd like. This one is set up with a few different splines. So everything spline here not only has their own biome setup, it also has its own spacing, so I can make it more or less dense very easily just in this area. I can even change the fall off curve at the end by swapping this curve out. You can see it is now much denser all the way near the edge versus something like this where it starts to fade out a lot earlier on while the middle is still relatively dense. And of course you can put in any kind of setup here you want, so you can get some really interesting designs where you have a now much denser center and more of a gradient outside. It is fully customizable per area. And while this is not going to cover absolutely 100% of everything you might need for a biome system, I am very open to expanding this into a series. If you see something you like here and you want me to show you how to build upon it, just let me know build onto what and how you want it to work in the comments below. But with that, let me show you how you set this up for yourself so you can have your very own biome system that works on anything in any way you want. Let's go. To get started, we'll of course need to enable some plugins. Go to Edit Plugins, search for PCG, and we want to make sure we have Procedural Content Generation Framework turned on, as well as the PCG Extend Toolkit. If you don't have PCG-EX installed, I'll leave a link to the Fab website with it down below, so you can grab it for yourself. I also have a few tutorials on the channel you could check out to get yourself accustomed to it, but we're going to be using just a couple of notes and of course guide you through it for this biome setup. It just makes the actual fall off section of it much easier, and it allows us to have a lot more control down the line if we want to introduce more complex things into our biome system. So while it is not required, it is going to definitely make this process a lot easier with it. So make sure you have both of these turned on. It will automatically enable this one for you when you enable PCG-EX, and then go ahead and restart your engine as needed. To get started with this entire thing, we're going to need a few things. We're going to need data assets, which is what we're going to be using to easily swap our biomes around. We're also going to need the spline setup that's going to store our biome, and of course the main PCG graph as well. Let's start with setting up the data asset. That's going to be the simplest one, and then we can move on to the rest. I'll go ahead and make a new folder for myself. Let's call this data assets, so I can just put all my data asset stuff in here. For that, I'm going to right click, search struct, and grab ourselves a structure, and this is going to be our S biome. I'm going to open it up, and here we can add the things we need for the biomes. I'm going to add the mesh, the weight of the mesh, which is basically how often does it appear relative to something else, and I'm just going to add the scale. You can of course add minimum scale, maximum scale, rotation randomness, offset randomness, whether or not it faces up or along the normal of the projection of the landscape. You have full control over every single aspect of it. I'm going to show you this as a base. If you'd like me to implement more and show you how to do that, please let me know, of course, in the comments below. In the meantime though, we're going to get started with just the mesh. Let's call it mesh, and I'll change the variable type to static mesh object reference. I'll add a new variable. This is going to be our weight, and I'll change the weight here to be a float, and add in one more variable. This is going to be our scale, and I'll leave it as a float as well. And in the default values here, I'm going to change the weight to be 1, so it's 1.0 by default, and the scale also to be 1.0 by default. My default values is here on the right side. Yours might be a bit down below, or might be a different tab. It depends on your configuration. You can always get it under Windows default values right there. The reason I have scale here as a float instead of a vector is because this is a simple example. I'm just going to scale it uniformly. Once we have that, we need primary data assets. So right click, go to Blueprint class, open up all classes, and search for primary, and you'll see primary data asset. You don't want the asset label, you want the primary data asset. Hit select, and it's going to be PDA for primary data asset underscore biome, and we'll open it up. It's not going to have much of anything in here, but all we need to do is add ourselves a new variable. I'll call this biome info, and the variable type is going to be the struct we created, s underscore biome, and go ahead and select it. I also want to make it an array so we can have multiple things. So I'm going to right click to make it an array, and I'm also going to hit the eye icon to make it exposed. Then go ahead and compile and save this. It is all we need to do in this entire PDA setup. From there, I can finally right click, go to miscellaneous, and grab ourselves a data asset. Now keep in mind, there's two here. Both are called data assets. They just have different icons. We want the one that looks like a pie chart. So grab grab that data asset, and it's going to ask you for a class. Well, the class is the one we just created, so it's going to be PDA underscore, and there it is, PDA underscore biome. Go ahead and select it, and we'll just call this DA underscore for data asset. And now this is the biome that it's going to be. So for example, I can call this forest. And now if I go ahead and open it, you will see there's our biome info. And if I add a new entry here and open up the index, you will see there's our first entry. We could tell the weight of this object and the scale of it. So for example, on this first one, I can just search for PCG tree and grab PCG tree 1, and I can add a new entry and populate it with a few more trees. So we have some variation here. On this last one, I'm going to plug in a little seedling here, and I'm also going to make it far more often to appear, 10 times more than the trees. So we have a little more grass everywhere compared to the trees. But that's all we need kind of for this basic biome. From here, I can go ahead and just duplicate this and call a different one, for example, desert. And in this one, I can go ahead and swap out all of these meshes for a desert. For example, with some cactuses and some boulders, maybe I want the cactuses to be twice as big, the boulders to be 5 times as often, and also twice as big. We have all this control here, but the main thing is we now have the option of creating the biomes however we wish. And if you're wondering where I got the cactus from, I went ahead and enabled the PCG Biomes and PCG Biome Sample plugin, and in there I was able to just grab those extra assets that aren't available in the default PCG setup. You just grab them, copy them somewhere else, and then you can turn off the plugins again. That's only if you want to use those same ones just for the temporary version. With our data assets pretty much done, let's go ahead and set up our PCG graph with the spline. We're going to right click, go to PCG graph. We're going to create an empty graph. It's going to be our PCG underscore spline biome, and we're going to need the actual spline setup. So I'm going to right click, put a blueprint class of a type actor, and it's going to be our BP underscore spline biome. Let's open up the blueprint, and here we're just going to add a spline, a regular spline, and then all I'm going to do is kind of just drag this out a little bit so it has a far greater size, and I'm just going to drag this out basically into a square, then search for closed loop, and enable that. So that way we have a nice closed loop here as a large, basically square. We'll add one more component. This is going to be our PCG graph, of course. So we'll get the PCG component, and then the detail panel for the graph, we'll plug the graph we just created, which is our spline biome. While we're here, we might as well add the variables we want to control. Now you can have these on the actual PCG component, or you could put them on the actual blueprint. By putting it on the blueprint instead of having them just in the PCG component, you just don't have to select the PCG component to go to your attributes. It's just a little more convenient. Honestly, it's just a usability thing. Do whatever is easier for you. In my case, I'm going to need a few variables, starting of course with the biome asset, which is the biome that we're going to be setting up in here. The type of variable it is going to be our actually PDA underscore biome, and it's going to be an object reference. It is not a data asset biome. It is a PDA biome, which is the base one. And then of course you want to turn on this I to make it exposed. And then if I go ahead and compile this, I can put in a default here. So I'll actually go ahead and select from the drop down. Here you see we have the desert and the forest. We'll make the forest the default. That way we have something there. By default, we don't have to make sure we always plug it in. We can immediately see what's going on. The other thing I want to put in, of course, is point spacing. So that way, if we want a denser or less dense biome, we can just do that here. We'll make that of a type float. Is going to be exposed. And I'll compile to adjust the default point spacing. We'll set it to be something like 500 by default. And the last one here I want to do is add the curve control you saw earlier. So I'm going to add the falloff curve. And the type here is going to be a curve float. Now, careful, there's a float curve under structure. We do not want this one. We want the object type curve float object reference. And of course, make it exposed. And in here for the default, you can already select one of these as you'd like. There's a few here you could see of different curves. There's some that are built into PCGEX. Some of them are defaults, but to make your own, I'll just go ahead and put it into a new folder for myself. I'll say falloff curves. And here, all you do is right click, go to miscellaneous, and you'll see right here, curve. You just grab a curve. It'll ask you what type you want. We just need a float curve. Go ahead and select it. I'll call this C underscore linear. Open it up and you'll be met with this. Now you could put the curve everywhere. For what we want, we really need 2 points to get started. So I'm going to right click, click add key or press enter. You'll see one has been created right over here. And then in the top left corner, right next to selection, you have the value. You basically have the x-axis and the y-axis. So on x, I'm going to make it 0. So it's going to be 0, 0 for the first one. Then if you deselect it and you right click again, you can get add key again. And this second one will be at 1, 1. And you'll see now we have a key that goes from 0, 0 to 1, 1. If I press F, it'll frame the entire thing. And if I want it to be slightly curved, I can select both and press 1, and you'll get this nice curve. The 1 key, if you're wondering, is from right clicking, and right here, 1, 2, 3, 4, 5, it is the different type of actual blending between the 2 points that we selected. So if I hit 4, you see I'm back to linear. 1 gets us this curve. But if I want to, of course, I can add more keys, I can control this any which way. So from here, I can just duplicate this and I'll just can say curve up. And this one, I can add a key and just have this one be a little more angled upwards. And then get another one that's curved down and make this one curved downwards. The main thing here is we have a few different versions now. And in the fall off curve, I can go ahead and just make the default here C linear. So our defaults are the linear curve, 500 point spacing, and the forest biome. So at this point, let's go ahead and take our spline biome and just drag it out into the world. In my case, I made it quite large, so you can really see it. We'll just put it right over here and open up our PCG graph. So now let us get started with the actual PCG graph itself. We're working with a spline. So the first thing we do is right click and search for get spline data. And then we can go ahead and use a spline sampler. Now the spline sampler, instead of on spline, we're going to go on interior. We're going to check unbounded. So use the entire spline. If you have a volume in the spline, you could just use the volume and then it'll just show up within the volume and where the spline overlap by default, or you can check unbound like I do here. Then we have the interior sample spacing. Now we created a variable for this. So I'm going to right click, search for get actor property. And inside of this property name, that's where we put the variable name, which in our case is point spacing. It might be easiest to just duplicate this over. If you do make a typo here, it will say error. So you know you have a typo, but if you got everything typed incorrectly, no errors will be found. And then from here, I can just plug this into interior sample spacing, which is right here near the top. And that's all I need to plug into here. At this point, I can already go ahead and debug. If I just add a debug node, you will see here all the points. Fantastic. Now, one thing that will help us greatly is if we got these points to automatically give us a fall off from the middle to the outside. So we immediately have a way of telling where the point is relative to the shape. And you can do that right in the spline sampler using this interior density fall off curve. If I double click on this, it'll give me a larger graph I can work with. And from here, I can right click, add key to interior density fall off curve. It'll just put it wherever I clicked, but I want it to be similar to what we had before, which is 0 and 0. And we'll add one more, this time at 1 and 1. And if you want, you can even click zoom to flick horizontal or vertical to fill it in. But there's our curve. From here, I can close this. You can even fill it in here, as you can see. But what this does is with our still debug enabled here, you can see the middle ones appear a little bit darker. In fact, if I make this a bit bigger, like really big, you could see, there we go. Now we're getting really dark in the middle. So as you can see, we are automatically getting a variation here. If I make this even bigger, you could see 0 is pretty much at the middle, and then it falls off to white. But as you saw with this small version, it doesn't go all the way to 0 right away. There is a distance that you need to hit, but that is fine with us because now we have some kind of information about how far away from the edge it basically is. 1.0 is at the edge, 0 is as deep inside as it gets. And now what I want to do is offset these points randomly based on the actor spacing. So if the actor spacing is 100, I want to be able to move the points 50 in any direction. So that way, even if any of them move, they will not ever overlap each other. They'll not go over to the other point's location. So the maximum they can go is 50 in any direction. So from here, I can just use a simple transform points node, open this up, and then I can right click and search for make vector attribute. Instead of vector 2, we want regular vector of 3 values. And then we can take this point spacing and then search for divide and divide it by 2. So we get the half of the distance. And we want to offset that in X and Y. So if it was 100, it'll be 15 X, 15 Y. That is going to go into our offset max. And we want the negative for offset min. So I'm going to just drag out of here and multiply it by -1, which effectively gets us the minus 50. And that's all we really here. So now if I press D on this transform points, you will see that our points are now scattered randomly here. And if I want to, with the main spline selected, I can go to point spacing, change that to 300. And now we have a lot more points, 50, tons and tons of points, but all of them will be offset relative to half of their size. So I know in almost no case I'll have a perfectly overlapping point. You will still occasionally see a point overlapping like this, but the center of it where the actual location is technically a bit apart. So fantastic. We now have some points scattered around. Now let's go ahead and filter them out based on the density. And this is where we use the PCGEX that we have enabled. To do this, we just need to right click and search for PCGEX Uber filter. And we just want this, grab this Uber filter, the first one here. This transfer points is going to go into the in, and now we can plug in filters. Well, the filter I want to do is actually random. So I'm going to right click and search for filter random. And you want the PCGEX filter random, not the random choice. And that can go into the filters. To show what happens from this inside, I'll just add a debug node here. And then you might notice all your points are gone. This is a bug with some PCG displaying incorrectly. All you have to do to fix this, right after the spline sampler, just add yourselves a bounds modifier. You can leave it on default, which is just scaling it on 1 across all axes and plug that through, and you will get your points back. And if I enable and disable the Uber filter, you can see it is uniformly cutting out about half of them. In our case, we don't want to cut out about half. We want to do it a little more controlled. So on this random, instead of threshold input constant, we can change this to an attribute. And the attribute we want to set is a point density. As you recall, we set the density in our spline sampler here. So they all have different densities, and it comes with a weight curve. So now as you can see, it is cutting out a little bit differently now. And if I go ahead and expand this to make it considerably bigger, you will see that we're getting a lot more in the center and a lot less on the outside. We already have basically a gradient transition from the middle to the outside, where there's more in the middle and less there. And that's just using the default weight curve. But we made it weight curve, so we can actually control this. So I'm going to right click, get actor property. In the property name, I'll use falloff curve, which is the name of our variable, and we'll just plug that into weight curve. Now you won't see too much change, but now if I go ahead and change the actual curve here, there's a curve up, you'll see we now have more of them out on the outside. Or if I change it to curve down, you'll see it is now considerably faster of a fall off. You still get a denser middle, but the fall off is now much more towards the edge. And now we can just really quick control how we want this. At any time, we can duplicate this, make a new one, for example, C wave, and we can do something along these lines, for example, and just make a really weird one, plug that one in, and you can see you get a different result, which is, I find really nice to be able to control it per biome, however you'd like. So wonderful. We now have our second variable in place, which is the curve. Let's go ahead and actually add in the data asset, the thing that holds all the biome information, which is kind of important. To get it, once again, right click, get actor property. This time the property name is going to be biome asset, which is the name of our variable. Then you drag out from the get actor property and search for get property from object path. Now by default, it'll throw an error because it hasn't been set up, but with it selected, all we need to do is give it a property name. The property name is this one here that we put into our PDA biome. So in our case, it is biome info. So in here for property name, we put in biome info and press enter. If I go ahead and press A at this point with our spline selected in the bottom left, you will see there's our mesh populated, there's the weight, there's the scale. So now we just need to apply this to the actual points. From here, we just drag out, search for match and set attributes, and the match data will be this get property from object path. And on this match and set attributes, it comes with an automatic match weight attribute. So we'll make sure that is on and have our name of our variable put it in here, which in our case is weight. So automatically assign the weight when it's spawning, sort of like the static mesh spawner, to use that variable as the chance of it spawning. So fantastic. We got the mesh taken care of, basically. We got the weight taken care of. We just need the scale. And setting the scale is very easy using this. From the match and set variables, drag out, search for set attribute, and you just want the math operation set. And we can plug the out into both of these in A and in B. Input source 1 will be point scale, and input source 2 will be just scale, no $sign. This second scale is the one from here. As you can see, it's named just scale. There's no $sign there. If I press A on, for example, the Uber filter, you'll see there's a $sign scale .z, y, x, which is different. This is the one from the point information, while this is just an attribute. So this goes ahead and sets this float to the vector. If I go ahead and add a debug here, you'll see everything looks pretty much as it did before. But if I make one of these trees, for example, 2, you'll see some of these points have gone bigger. If I change it to 5, it gets bigger, and it'll get bigger just for the one that I'm changing. In this case, it just happens to be the first tree. The main thing is we can tell it's working. Fantastic. Now from here, while our spline is in the air, it would be nice to have it be actually on the ground or wherever we want it. Instead of using this cube here, I'm just going to remove it. I'm going to get ourselves a landscape. So we're going to go to selection mode, change that to landscape, and I'll just create a new basic landscape here. And then I'm going to zoom out, and I'm just going to slightly warp this with some randomness here by using the sculpt. So we have uneven flooring here. So there we go. We have a little bit of hills, a little bit of flat areas. So now we want to have this spline project onto this landscape from anywhere up here. And we also want it to actually project onto meshes, not just this landscape. So in fact, I'll also add a basic cylinder here for demonstration. We'll go ahead and put it here, maybe add some more here so we can see what happens when we use regular objects. And the way we're going to do this is by tag. So I'm going to actually select all 3 of these, search for tag in the detail panel, and we can add the actor tag to all of these at once. By hitting plus, and we can give this an actor tag. Let's call it biome floor. So anything that will have this tag will be able to project on top of. So now to use it, we'll turn off this debug, drag out and search for projection, and the projected target will be world array hit query, and that is going to go into the projection target. Now on this world ray hit query, you do need to customize this. We're fine doing line traces. That is fine with us. But we do want to set the ray parameters. I'm going to turn this on, and now we can specify the ray origin, the ray direction, and the ray length. By default, the ray origin is 0, 0, 0, and the ray length is 100,000 and is going down. So that means in this scenario, if your landscape happens to be above 0, 0, 0, it will never hit it because the ray will start below it. So what we want to do is make sure that the ray always starts above wherever your highest point would be. And let's say it'll start 10,000 units up in Z. It'll go down 100,000 units. We can even say it goes up from 50,000 units and then goes 100,000. So it'll be basically 50,000 positive, 50,000 negative, and anything in between, it'll hit the first thing. And also under filtering, we need to make sure it only does the tags we want. So under actor tag filter, we want to go ahead and include and type in biome floor, which is the name of our tag. And here you can also filter if you want to select the landscape or not. But for us, this default is just fine. So already from this projection, I can go ahead and debug, and you'll see there it is projected onto the landscape. If I take this spline and move it over here, you will see it is now projected not only on the landscape, it is also projected onto this mesh. If I want to, I can of course add in a normal filter, but those are more advanced stuff. And like I mentioned, if you want to see me progress this even further to add more control, let me know in the comments below. The final thing I want to do to this setup is rotate the points because they're still all facing the same way in terms of the Z axis. So at the very end here, I'll add another transform points node, and all it's going to do is rotate max on Z will be 360 degrees, which as you see will now rotate the points around. Perfect. And what if I told you we're pretty much done with the PCG biome? We haven't spawned anything, but that's more or less what we need. The only thing left actually is take this output that comes with every single graph, bring it over to the end, and adjust its pins to accept the allowed type of point and change the pin status to normal. And we can just pass out these points from the transform points to the output. We're actually not spawning anything in here. This is what's controlling and doing all the operations of the biome, but is doing none of the actual spawning in the end. It has all the information needed to spawn it, but it's not doing the spawning. Now, the main thing here is that means theoretically, you can have an entirely different system because from here on, all I'm going to be using is what is outputted in terms of points. And as long as you have the mesh information pretty much stored on the points somewhere the same way I did, you could spawn it in any way using any method. You have it be in the air, you can have it be in the ground. You don't even need to project anything if you don't want to. It'll still can all work together. What do I mean by this? Well, let me show you. Back in our content browser, we'll go ahead and create the actual biome graph. I'm going to right click, go to PCG, go to PCG graph, create an empty graph. This is going to be our PCG biome system. And then you go ahead and drag this out into the world. And I want to, of course, probably make it big enough to envelop most of this. I'll set it to be something like 250 by 250, which kind of gets us the entire area that we need here. And I'll just make sure it has enough height by changing it to 100 in height. So that way the splines are inside of these bounds, which is going to be very important because depending on the size of your landscape, if your spline is above, you'll not actually get any spawning. So make sure your spline is within the bounds here. By that point, let's go ahead and open the PCG biome system. And this is honestly going to be extremely simple to set up here. Because all we need to do is right click, get PCG component data. This node gets us everything we need by changing the information for it from actor selection by tag to by class. Although you could absolutely keep it by tag, we're just going to put it all inside of BP spline biome. That is the actual actor that's holding all this information. And we're going to make sure select multiple is turned on. Although I have found that it still selects multiple even when this is not enabled. So I'm not 100% sure if this is required. But from here, I can just select it and press A. And all of a sudden you'll see there's a bunch of point information. And if I scroll all the way to the right, hey, there's our mesh. There's our scale. It has the information. So from here, we can just do static mesh spawner, change the static mesh spawner to by attribute with the attribute called mesh, because again, that is what we call the variable in the structure. And that is what you see here as it's calling mesh. There's our forest spawning on everything how we wanted. There's our little guys there. There's the trees. Now it might be way too many trees, but we could control that dynamically by going here and changing the seeding here to something like 50. And you can see there's now a lot more of the little ones, but they're absolutely tiny. So let's make them something like 2.5 times bigger. And now look at that. We now have a lot more of the little guys and a forest. Now, one thing you might notice is it is automatically angling to the actual geo. Now, depending on your setup, you might want this, you might not. You might want to add a control in the structure to control per object whether or not it does. In my case, I'm going to be very simple about it. In the projection, I'm just going to turn off project rotations. This will just make it so everything automatically faces upwards, which is more natural for actual foliage like this. this, so it'll automatically just take care of everything for me. But now what we can do is take our biome spline, I can duplicate it somewhere else. You can see it's automatically being populated here. We can keep the overlap if we wish. All we do is in the blueprint spline, change the DA forest to DA desert. And you can see we now have a new desert. Way too many points though. Let's make this a 600 point spacing. And now we have a desert. I've gone ahead and made a few more data assets here. So we have a few more biomes, as you can see. And one thing I noticed is these boulders sometimes disappear from some of them. If I regenerate this, should say it's 550, then these sometimes disappear. Anytime any of these disappear, all you do is select the main graph and then go clean up, generate, and everything will come back. And you can see the boulders are back here as well. It specifically only happens with these boulders. I do not know why, but everything else is fine. You can see we can now control every single one of these, control the fall off, control how many there are. If I find that, you know what, this spruce area, I want more of them, I can just change this curve to a curve up. And you can see we now have a much denser forest that falls off a lot more steeply. Or I can keep the fall off as is and just decrease the point spacing. And so we still get the fall off, but we just have far more things there. You can see as I change those, the rocks disappeared again. Again, I'm not sure why. It's specifically the boulders that give me trouble. So again, clean up, generate, there they are. But the main thing that we have left to do is, well, make this actually partitioned, because we don't want to load the entire area here at one go. We only want to load what's around the player. And thankfully, that is very simple to do with our setup. The first thing we need to do is select the biome system, scroll down to the PCG component here, select it, and then right here on top, you will see is partitioned. We want to turn that on. And we want to change from generate unload to generate at runtime. Everything is going to disappear. Don't worry, we're not done yet. Go to the PCG world actor 0 here, and you want to turn treat editor viewport as generation source. So that way it treats, well, the viewport as though it was the player, but you'll see it's back, but at a certain distance, it comes out and leaves again. So we're still not fully done. The final thing is here on the biome system, we want to turn on use hierarchical generation. And then for the high gen default grid size, we want to set it to unbounded. We want to set it unbounded because that is what is going to be coming in. By having it a smaller value, I'll show you what happens. If I set to this like 6400, I can zone in and out full biomes. So as I fly out and in, the entire biome loads in and out, which depending on what you want, maybe is good. But in my case, I want to partition the entire thing, including inside of each biome. So to do that, I'm going to change the high gen default grid size to unbounded. And then I'm going to take this, move it over to the right. From this get PCG component data, I'm going to search for change grid size. And here I can specify the grid size I actually want. So in this case, let's go with 6400. And then from the change grid size, we just drag out and search for an intersection node. Grid cell volume goes into source 1. You can see we got another conversion node here. And this final one's going to go into static mesh spawner. So we are left with kind of two conversion nodes here. The main thing is you can see as I fly around, we're just generating the chunks within the biomes all together. So if I was the player, I would just load in kind of what is needed just around. And guess what? Because it's all set up here in this section, you could even set up a system where you have this be dynamic to change the grid size based off something in the biome. So maybe you can set up something where, hey, this biome generates at this distance and this one generates at this distance. Or you can have different areas of it or different parts of it generate at different sections. You have a lot of control here because this is all that is taking care of the entire actual spawning and partitioning of everything. All the logic is inside of this graph here, which isn't very big. And all it is just outputting points that happen to store the information from our data asset. Nice and simple. To make this a little bit nicer though, I'm going to select the landscape here. I'm going to give it a material I got from Megascans. So we got a nicer floor here. And I'm going to add a post-process volume, search unbounded to turn that on. Go to exposure, turn metering mode to manual, exposure compensation to 10. I'm going to tweak the lighting to make it a little bit more moody here. And I'm going to turn on light shaft bloom to get ourselves some really cool looking light shafts. Final thing is in the post-process volume, I'm going to go to the global color grading, go to gamma and override that to just be a bit warmer. And you can see we can get some really cool effects. You could even add a little bit of depth of field to make this even more cinematic, whatever you wish. So that's my kind of basic biome system. It allows you to put biomes wherever you want. It allows you to put biomes on objects, on landscapes, landscapes. You can have it floating. You don't even need to project anything. You have so much control with the system. Now, you do have to set it up for yourself, but then you'll also know how it's set up and be able to modify it as you wish. Now, if you want to play around with this biome system yourself, and you don't feel like setting this all up for yourself, you can go pick it up on my Patreon, where you can join these wonderful people here that support what I do. It really means a lot. And if you'd like to join our community, the link to the Discord is down below as always. And as I mentioned before, if you want to see this as a full series, let me know in the comments below. But if you want to see some more awesome PCG tutorials, check out this one right over here, which is one of my 5-6 favorites.